Hello, everybody. We are going to be looking at LA-8 today. This is the last assignment. I'm not going to play too many tricks on you today. So just go ahead and follow along. Do your best. Pause the video at any times you need to see fit. We'll just go ahead and get started. So, first off, make sure you install and then load your packages. As always, set up your working directory if you need to. That is, again, only if using R and R Studio. And then go ahead and download the CSV files from Canvas and read them into your assignment. Once you do that, you should be left with a codebook and the full data set. So the first question, you're going to create a new variable called Asia-Europe. And that is going to equal Asia or Europe. So as always, we're going to start with our with what we want to call this new data set. I'm going to call it COVID data. I'm going to assign this to the results of what I am going to write here. So I'm going to first start with my existing data set, the COVID full. This should have all of my current data in it. I'm going to then run a pipe operator. Click enter. And now I'm going to create a new variable. So I'm thinking of using the mutate function. Anytime we're creating a new variable, that's what we're going to do. And then this new variable is going to be called Asia-Europe. And this is going to equal the case when the country is either in Asia of China, India, Japan, Singapore, South Korea. So I'll just go ahead and copy those into my combine function. Make sure I'm putting them each into quotations. Cool, and then using my little squiggly line here, I'm going to call this one Asia in quotations, comma here, and then do the same thing for Europe. So this should be a review from what we did in LA-6 and LA-7. So I'm not going to spend too much time describing it here, but just remember each and every country here needs quotations. And make sure you use this little squiggly line here, not a straight one. Make sure your consonant is in quotations as well. Make sure the two functions you opened are closed down here. So now when you run this, you should have a new data set with one additional variable. That variable is Asia-Europe. Next, we are going to obtain the descriptive statistics. So that means the mean and the standard deviation. So we're going to start with our new data set. I'm just going to copy and paste that, the one that we just created. I'm going to run a pipe operator. I'm going to filter for either Asia or Europe. So this should be the new variable I created. Double equal sign, Asia, close the parentheses and the quotations there, pipe operator, and then I'm actually going to use describe because this will give me all the descriptive statistics for hand washes. And I know it's called hand washes because I looked at the code book, and then this is the number of times that people have washed their hands on the previous day. So now when I run that, I'll get the descriptive statistics, most specifically the mean and the standard deviation for Asia. I'm going to do that for Europe as well. Make sure that you see I have two different data frames here. This is from me doing it earlier, but this is from me doing it now. Make sure you're using the same data frame. Cool. So now we will move on to 3. So we are looking at the number of times people have washed their hands in Asia versus Europe. So our 2 variables we're going to be looking at are Asia, Europe again, because we have Asia compared to Europe, and then we're going to have hand washing. So big thing, we're going to have to determine which is a continuous and which is categorical. So we know that Asia and Europe is we only have 2 options there, so it's categorical. Hand washes on their hand is a continuous variable because it's a numeric kind of going towards infinity potentially. So starts off, it's asking us to state our hypothesis. Remember, a null hypothesis means there's no significant difference, and an alternative is saying that there is a significant difference. This is the case for all of your hypotheses. So using the flowchart from LA-7, we are determined that the dependent is continuous, and then the categorical is, or the independent is categorical, and there's only 2 categories, so we will use the t-test. So I will again start with my new data frame, which I call COVID data. I'm going to run my pipe operator, and then I'm going to do t_test. Start with my dependent variable, use my little squiggly line here, and then my independent variable. When I run this, I should get a nice little chart here. My test statistic is negative 12.2. You can see that it's in this table, and then my p-value is 6.549 times 10 to the negative 23, which is a really small number, which is smaller than 0.05. So we are going to assume that the alternative hypothesis is true, and there is a significant difference. Cool. Moving on to 4, we first have to determine our independent and dependent variables. So the independent is how many times the people left their home, which is times left home in the code book, and this is a continuous variable. And the dependent is the total number of contacts, which is also continuous, which is coded in the code book as total_contacts. Once again, our null hypothesis means there is no significant relationship, while our alternative assumes that there is a significant relationship. So that is how you should write that part of the question. Going through our flow chart, we are going to now use the correlation test. The correlation test is the only one that isn't in your code, the flow chart, so I will help you work through that. So we're going to start with the core.test, cor.test, open that parenthesis, and then here we are going to have to determine our data frame. So here is our data frame, which is not how I wrote it, so it should be COVID data. I'm going to then use my money sign here, and then we are going to be examining the total contacts in the COVID data. That's what that money sign is depicting there. So COVID data, money sign, total contacts, comma, and then do the same thing here, but money sign times left home, close that, and now when we run this function, we should get this Pierce's product moment correlation, which should give us the test statistic, which is nomenclated by T, the degrees of freedom, which is 289, and then the p-value, and then we also get the coefficient of the relationship. So we can assume that there is a positive slope of 0.3432237 between the total contacts and the times left home. So just looking at the data here, here's our p-value, which is smaller than 0.05, so there is a correlation, and it's a positive relationship of 0.343. Cool. Number 5, again, first things first, we want to determine our independent and dependent variables. Again, Asia compared to Europe, so we're going to use that Asia-Europe one, which is a categorical. And then lives impacted by COVID is the dependent variable, and it's majority life impacted, and this is also categorical. So if we follow the flow chart, we're going to get to the chi-square test. Here again, you're going to state your null in your alternative hypothesis. Null, again, being no significant difference, or alternative being that there is a significant difference. Here we're going to run our chi-square test. This one's probably the most confusing, just by the way it's kind of written out, but I'll work us through it. So go ahead, write the chi-squared test, which is CHISQ_test. And then you are going to open up the function. You're going to assign x is equal to the COVID data, money sign again, and then you're going to do the Asia-Europe variable, comma, y equal to COVID data, and then majority life impacted, comma, and then here, this is kind of optional, but you can decide what your p-value is going to be, and I decided I'm going to call it 0.05. When I run that, don't worry about this money sign, don't worry about this warning message, because it's just saying that we could put in more information into this function. But we do get our p-value here and our test statistic. So we know that the degrees of freedom is 2, and that the p-value is less than 0.05. This will help you determine your critical value. Just a little helping you out. This is 5.99, and so when you compare the 22.5, which is your test statistic, to 5.99, you can reject the null hypothesis, and so the test should support that there is a significant relationship here, or significant difference. And then we can also look at this data in a traditional way. So if you run this function, which filters, we're just going to look at the in the COVID data data frame. We are going to filter just for the Asia-Europe, is either equal to Asia or Europe. We're going to group that, and then we're going to look at the frequency of majority life impacted, and once again, this is kind of optional, but if we can see that in Asia, 11 people said that their lives were impacted, or the majority of 11 said yes and 43 said no. But while in Europe there were 43 populations that said yes and 26 said no, so we can see that there is a difference. Only like a fourth of the amount of people in Asia thought that their lives were impacted, while about twice as many people in Europe thought their lives were impacted. So that is how we get through the assignment. The bonus one is a correlation test, so you should be able to work through that. Bonus two, I'll go ahead and work us through it as well. So we're going to start with our data frame. Here we're going back to when we were doing the ggplot. So we're going to have an X, which is going to be the new Asia-Europe one. Y is going to be hand washes. We want to use a bar graph. This is important because we're going to have it, the y-axis or the x-axis, be the identity of the Asia or Europe. As you can see down here, I've already run this. So by putting in these parameters, we're going to get this x-axis to have the bars labeled, and then we are going to use our labs function to first off null the x-axis, which is going to get rid of the labeling, and then we are going to label the y-axis, and then finally we're going to use this theme function to say axis.title.x. That is your x-axis title, and then we are going to leave that blank. So now when we run this, we are going to get this, and we'll have our y-axis labeled, we'll have our x-axis ticked out. So I know I did that quick. This is a bonus, but you should be able to work through it. Again, the first bonus, correlation test, I showed you how to do that earlier. Very similar to what we just did before, but you just have to determine which is your independent and which is your dependent variable. All right, thanks y'all. Let me know if you have questions. Happy Thanksgiving. See ya.